Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM 2022, problem number 39. The problem says that let x1, x2, x3, x4 be a random sample from a continuous distribution with PDF fx is equals to 1 by 2 e to the minus mod of x minus theta, where x is a real number and theta is also a real number. Theta is the parameter, right? Theta is unknown. Let the corresponding order statistics be denoted by this x order 1 up to x order 4. Then which of the following statements is or are true? So it is a multiple select question. More than one options may be correct. So here, option 1 talks about the unique MLE of theta. Option 2 talks about the sufficient statistic. Option 3 again MLE of theta into theta plus 1, and the last option talks about complete statistic. So let us first try to solve the MLE part of the problem. So x1 through x4 follows IIT Laplace theta comma 1, right? Because this is nothing but the Laplace distribution. So this is Laplace theta comma 1. That if x is 1 by 2 into e to the minus mod of x minus theta, right? X is a real number. So the likelihood function L of theta given x curl, this x curl is a vector, this sample value is product of this quantity, right? Because obviously they are IIT, so this is nothing but 1 by 2 to the 4 into e to the minus summation I running from 1 to 4 mod of xi by xi minus theta, right? Modulus of xi minus theta. This entire quantity is the likelihood function, where theta is a real number, theta is an unknown real number. Theta, the function is this L is a function of theta, where theta takes any real value. Now we have to maximize this function theta, right? This function of theta, this L of theta. Now L of theta given x vector is maximum if this quantity is maximum, right? Because this is constant. This 1 by 2 to the 4 is constant. So this quantity is maximum if this quantity is e to the minus of summation. This thing is this entire thing. This function is maximum, right? Now think about it. This is actually e to the minus, this function is nothing but e to the minus t, right? So we know that this function is maximum. This entire thing is maximum. This thing e to the minus of summation of mod of x minus theta, if is maximum if this quantity, that means this particular quantity summation mod of x minus theta is minimum, right? This thing is minimum. If this thing is minimum, this thing is maximum. Now this is nothing but the mean deviation about theta, right? The mean deviation of the values of x1, x2, x3, x4. Now the mean deviation is minimum when measured about the median, right? So that means for theta equals to the median of x1, x2, x3, x4, this quantity is minimum. Now there are four values, right? There are four values. So the MLE is actually nothing but the median of this quantity. But since there are four values, the median can be anything in between x order 2 and x order 3, the middle two values, right? It can be anything. Since the median can be any quantity between these two values, that means the MLE of this theta is not unique. MLE does exist, but it is not unique, right? Any quantity, any value between these x order 2 and x order 3 can be an MLE of theta, right? So that means x order 2 plus x order 3 by 2, that means the average of these two, it certainly lies between these quantities, right? X order 2 and x order 3, this quantity, the average of these two. So it is one of the MLEs of theta, not the unique MLEs, right? It is one of the MLEs. This is an MLE, but not the only MLE of theta. So option A is not correct because it says that it's the unique MLE of theta. No, there does not exist a unique MLE of theta. So option A is obviously not true. Now, since it is the MLE, right? It is an MLE of theta. So if tau theta is suppose say tau theta is a function of theta, where it is nothing but theta into theta plus 1, then by the invariance property of the MLE, this thing, this x order 2 plus x order 3 by whole divided by 2 plus this thing plus 1, that means just substituting the value of the MLE of theta in this function, this entire thing is actually nothing but the MLE of this thing. We know that if suppose if we know that if t is a MLE of theta, then tau of t is a function, is an MLE of tau theta, right? The invariance property of MLE says that. So this thing, so we already know that this thing is the MLE, is one of the MLEs of theta. It is an MLE of theta. That's no doubt with that. So this thing, this just replacing theta by the MLE, this thing, this into this plus 1 is, this entire thing is the MLE of theta into theta plus 1. That means option C is actually correct. This thing is actually correct, right? So option C is correct. Now option B says that the order statistics, the set of the order statistics is a sufficient statistic for theta. Now it is obviously true, right off the bat, because we know that the order statistics, the set of order statistics is always a sufficient statistic for the parameter theta. It is always, we know that the set of order statistics is a sufficient statistic for theta. It is sufficient, we know that. We can even easily prove that. Try to prove that. It is very easy to prove that. So obviously option B is also true. It is sufficient for theta, right? Sufficient statistic for theta. Now the only thing remains is the complete statistic part. Let T denote this thing, this x1, x2, x3, comma x1, x2, x4, right? And we have to show or prove or disprove that this is the complete statistic of theta. So let g of t be a function of theta, which is nothing but x1, x2, x3 minus x1, x2, x4. So expectation of this thing is actually nothing but expectation of this thing, right? It is actually 0. Why? Because x1, x2, x3, x4, they are IID, right? IID with mean theta, right? Mean theta. Therefore, this entire thing turns out to be 0 because expectation splits out because they are independent. This entire thing turns out to be 0. That means expectation of g of t is actually 0, right? But g of t is actually not equals to 0 for all values of theta, right? Clearly see that because g of t is this thing. It is obviously not always equal to 0. We can clearly see that. Therefore, t is not a complete statistic of theta. It is not a statistic for theta. It is not, right? Because we have actually found a function of it whose expectation is 0, but it is actually not 0. We have actually found it. Therefore, the only options true for this problem are option B and option C. So there you have it, the solution to this problem. So do like, share and subscribe to the channel for more exciting problems. See you till next time.